Good morning, everyone. This is our second online lecture. Now, today, you can see here the title of the today's topic, that is further development of that embryo with the foldings of embryo. So, in this lecture, we are going to see, apart from the further developments right in that developing embryo, we will see the foldings of the embryo and what are the effects of this folding in the developing embryo. Now, apart from this, in this lecture, we'll come to know about the what is notocord, neural tube formation, subdivisions of intra-embryonic mesoderm. Last time we have seen extra-embryonic mesoderm. Then intra-embryonic cilium, allantoid diverticulum, and at the end the folding of embryo with its effects. These are the overall objectives of this today's lecture. Now coming to the first point, formation of notocord. What do you mean by notocord? It is a midline structure, extends from primitive knot. Last time we have seen the primitive knot to the procaudal plate. Last time we have seen what do we know the primitive knot, primitive strip. So from the point to the procaudal plate, the extended portion we call as notocord. Initially, it is temporary, then it becomes definitive. Definitive means final. What is a primitive knot? The antemost thick end of the primitive strip is called primitive knot, also called as primitive node or Hensen's node. Small pore appears in the primitive knot, that is called as blastopore. So this is new terminology here, blastopore. It is nothing but the small pore hole that are appearing in the primitive knot. And what is a primitive knot? It is the antemost part, which is a thick end of the primitive strip. So in this way, this notocord is nothing but the midline structure which extends from primitive knot to the procaudal plate. The new structure where the whole of the pore forming appears in its primitive knot, which is called as blastopore. Cells of the primitive knot multiply. So they multiply in numbers and extends between ectoderm and endoderm up to the procaudal plate. Last time we have seen about this procaudal plate, where the intraembryonic mesoderm is not entering into this area. So ectoderm and endoderm, they are remaining in touch with each other. And this is called as procaudal plate, and this is placed anteriorly. So the cells of primitive knot, after multiplication, they extends between ectoderm and endoderm up to this procaudal plate. This solid cord is called as notochordal process. It undergoes very changes and finally form solid notochord. Most of the notochord disappears, but part of it persists and forms nucleus pulposus of intervertebral disc. So, in other words, we can say this is the remnant of this notochord in the form of nucleus pulposus of intervertebral disc. You know that intervertebral disc, it has two parts. Out of the two parts, one which is called as nucleus pulposus, another is annulus fibrosus. So this nucleus pulposus is formed, or it is a remnant which is formed from the notochord. So in this way, we have seen what do we mean by notochord. So it is nothing but the elongated structures coming from primitive structure, not to the procaudal plate. So initially it is temporary, then it becomes final. Okay. What is the remaining structure? Remnants, it form the nucleus pulposus of the intervertebral disc. With the help of diagram, here we can see this. What do we mean by notochord? So most anteriorly, we know that in this diagram A, procaudal plate, where ectoderm and endoderm, they are in touch with each other. No intraembryonic mesoderm there. Same way here, cloacal membrane. This is a primitive strip. So primitive knot, which is anterior, thickened end is called as primitive knot. If you see in diagram B, blastopore, small depression from there, a hole is formed in this knot, and this is called as blastopore. In diagram C, so from here after multiplication, cells proceed in further direction up to the procaudal plate, and this notochordal process later on form final notochord. So this blastopore extends in further direction. In this, if you take the sections here, you can see here, this is a primitive strip, this is a primitive knot. Later on, multiplication takes place here with thickets, small pore opens here, it forms here due to the degeneration of cells that is called as blastopore. And this way, it extends in further direction after the proliferation of cells. Same way, this blastopore extends in further direction. So in this way, it goes there, goes until the procaudal plate. And this is called as the notochordal canal. So initially, you get thick one, then blastopore extends as a notochordal canal. Later on, it becomes again thick, and that forms the final or the definitive notochord. So what are the steps to form the final definitive notochord? First, notochordal process forms. Blastopore appears in the center of the primitive knot. Blastopore extends into the notochordal process and forms the canal-like structure, which is called as notochordal canal. Wall toward the ectoderm mix with it first and then disappears it. Later on, the remaining curved part becomes flat and forms the notochordal plate. This plate regains shape of the tube first and becomes solid, called as definitive notochord. So these are the various steps to form definitive means final notochord. Almost all get disappears, but small part form in adult the nucleus pulposus in the intervertebral disc. So this is the fate of the notochord. And these are the steps to form the final notochord or final definitive adult shape of notochord here. So with the help of diagram, you can see here, this is ectoderm, this is endoderm. You can see here notochordal process. Then we know that there is formation of blastopore and it continues as a canal there. So notochordal canal formation there. The central cells get divided and tube-like structure or canal-like structure forms. In diagram C, you can see the lowermost part, it fuses with the endoderm layer. So you can see here it comes and fuse mix with this endoderm layer. Coming to the diagram B, this mesh portion will disappear. So you get this concave part of this notochordal canal. In diagram E, we can see it becomes straight. So this curved portion will become straight here. So this is a straight and this is called a notochordal plate. Now we refer it as a notochordal plate. Later on it becomes concave again and these two ends comes together and it forms a final and definitive notochordal canal. And the cells inside will proliferate, they multiply and the canal will convert into tube-like structure, solid tube-like structure. And this solid tube-like structure is called as definitive notochord. Again, in further process, certain portion will disappear and remaining portion forms the nucleus pulposus. So this is the fate of the notochord. So in this way, initially temporary notochord forms. Later on, definitive or the final notochord forms. There are various steps here we have seen right from diagram A up to the F. And last one, right, definitive notochord forms. And out of that, certain will disappear and the remaining act as a nucleus pulposus of intervertebral disc. Come to the another term here, further development, formation of neural tube. Means the neural structures get formed from here, and that is called as neural tube. During this phase, we call embryo is passing through the neurulation stage. Neurulation. So neural tube forms the neural structures like this brain and spinal cord. Neural plate is formed from ectoderm. So it is ectoderm in origin. Initially, neural plate formation takes place. And where it forms, it is forming overlaying the notochord. So in the last slide, we have seen how the notochord is formed. So this notochord, just above it, there is ectoderm, and below that there is endoderm. So the portion of ectoderm above the notochord, it gets modified and it forms a neural plate. Neural plate converts into the neural tube, and this neural tube gives the nerve structures origin, that is development of brain and development of spinal cord. It enlarges anteriorly, embryologically you can see cranially, means anteriormost, and forms brain. Caudal part is tubular and forms spinal cord. So in this way, from the neural tube, two important structures, most cranially, brain is formed and most caudally tubular structure, spinal cord is formed. The process of formation of neural tube is called as neurulation. So during this phase, we can say embryo is passing through the neurulation phase. Means neural plate is formed, then neural tube is formed, and all that taking origin from ectoderm. Just the area of ectoderm overlying notocord, this is recognized as a neural tube, neural plate, forming the final neural tube. And this neural tube forms most cranial brain and most caudally spinal cord. This is the diagram A, then diagram B here, diagram C, and diagram D. Now in this you can see this midline structure, blade-like structure is notochord. There is a primitive strip, there is a primitive knot. The notochord is formed here, this is procaudal plate. By that time, there is a formation of intraeminent mesoderm which goes here inside. Now what we have seen in earlier slide, neural tube, neural plate and all that. So if you see this diagram, if you take a section here of XY plane, you can see here this is ectoderm, this is endoderm, and this is a notochord which is formed in the midline. Rest of structures we'll see later on regarding intraeminent mesoderm. Just concentrate here, notochord is formed. Then see the change in the ectoderm overlying the notochord. It becomes thick, it becomes modified, and this is called as neural plate. So it takes origin from ectoderm, just overlying the notochord. This neural plate gets converted into the neural tube, and neural tube forms most cranially the brain and most caudally the spinal cord. So in this way, here we can see the formation of neural plate, then neural tube, and embryo in the neurulation phase. Meanwhile, here we can see the intraembryonic mesoderm get formed, and it comes and it lies around this notochord, which is centrally placed here. Now the intraembryonic mesoderm get divided into the three parts. One which is around this notochord is called as, because notochord acts like an axis. Around it, the innermost part is called as para-axial mesoderm. This mesoderm is intraembryonic mesoderm. In last lecture we have seen intraembryonic mesoderm get formed. So that get divided into three parts. So most medially in the center around this axis notochord, so para-axial mesoderm. Later on, the most lateral portion, it is called as lateral plate mesoderm. And in between this para-axial mesoderm, lateral plate mesoderm, there is an intermediate mesoderm. If you take a section here, XY plane, you can see here, this is ectoderm, this is endoderm, and these are three divisions of the intraembryonic mesoderm. Centrally portion is a notochord. So it will look like this red structure. So just most medially placed intraembryonic mesoderm we call as para-axial mesoderm. Then most laterally placed is a lateral plate mesoderm, and in between that small portion is called as intermediate mesoderm. Now we have seen that by that time the neural plate is formed, it gets thickened anteriorly, later on neural tube formed, it expands anteriorly and form the brain. So cerebrum, cerebellum, brainstem and all parts of the brain get formed here, and it is fast developing. The remaining portion converts into tubular structure like spinal cord. Meanwhile, this intraembryonic mesoderm, what we call this green color, is paraxial mesoderm. So it becomes thickened, it becomes nodular here, and that get converted into the somites. So this is a very important change occurring. So what we have seen in this diagram, first thing is the neurulation phase, ectoderm, just above this notochord, it modified and formed the neural plate, the neural tube, it expanded and formed the brain and spinal cord. Later on, we have seen the intraembryonic mesoderm, how it divides into the three parts: paraxial part, paraxial mesoderm, intermediate mesoderm, and lateral plate mesoderm. So here you can see in transverse section, notochord. This is a paraxial mesoderm, intermediate mesoderm, and this is a lateral plate mesoderm. Later on, this paraxial mesoderm get converted into the somites. And you can see here, these are the somites. This is a notocord, which is central portion here, like an axis. Just near to it, it's a paraxial mesoderm, which convert into the somites. Then we get this intermediate mesoderm. Then we get here lateral plate mesoderm, and it is in touch with extra embryonic mesoderm. So this is the embryonic disc, and these are the changes occurring in the further development. So what in the previous diagram we have seen how the intraembryonic mesoderm divides into the three parts. So that is this given in description. Subdivisions of intraembryonic mesoderm. It is formed from the proliferation of cells in primitive strip. We have seen in the previous lecture how the intraembryonic mesoderm is formed. So it is nothing but the proliferation of the primitive strip. It does not enter at three levels we have seen, in which we have level as anteriorly procaudal plate, most caudally cloacal membrane, and in between that is a notocord. Intraembryonic mesoderm get divided into the three parts. Most medially placed around the notocord is paraaxial notocord mesoderm. Paraaxial means notocord is acting as an axis. So around it, it is called as paraaxial mesoderm. Then lateral plate mesoderm and intermediate mesoderm. So there are three parts, subdivisions of intraembryonic mesoderm. Paraxial mesoderm, we have seen about it. What it is forming? Basically, it is forming the important structure which is called as somites. So it lies on either side of notocord, becomes thick. Later on, this mesoderm gets segmented. So small nodular structures get formed, and that is called as segmented structure. And there are two types of these segmented structures. One is called as somatomere, another is called as somites. Somatomeres, they lie in the region of head. They are rounded structures. They are 7 in number, so they are less in number. And they forms bones and muscles of the head and jaw. So, this is one part forming from this paraxial intraembryonic mesoderm. So, somatomeres, which are 7 in numbers, and forms bones and muscles of the head and jaw. While the somites, they are 44 in numbers, and they are forming the rest of the structures. We'll see about something regarding the somites. They are cubical in shape and more distinctly segmented as compared to the somatomeres. Most primary somites are in occipital region. And what it develops? Occipital somites form muscles of tongue. New somites forms progressively caudal to. Overall, about 44 somites get formed. 4 occipitals, 8 cervical, 12 thoracic, 5 lumbar, 5 sacral, and 8 to 10 coccygeal. So this number comes to approximately 44 somites. And this somites has age of embryo post 8. So 12 weeks, then 40 weeks, or 16 weeks by that time. So that much somites get formed. So this is also useful to count the age of that particular embryo. Now this somite get divided into the three parts. One is called a dermatome, and this is involved in formation of skin. Another part is called as myotomes, that is involved in the formation of skeletal muscles. Myomes muscles, sclerotomes, vertebral column and ribs. So bone structures get formed from sclerotomes and somites. So very clearly, we'll understand at this level, somites get divided into the three parts. One is called as dermatomes, another is called as myotome, third is called as sclerotomes. And these are the derivatives from these dermatomes. Derma means skin, myo means muscle, scleromeans concerning the bony part, vertebral column and ribs. So these three structures derive from somites, and these are the structures derived from these three parts of the somites. Coming to the formation of intraembryonic coelom. Like in extraembryonic mesoderm, we have seen the formation of cavity, and there we have called as extraembryonic coelom. Same way here, cavity get formed within the intraembryonic mesoderm, and that is called as intraembryonic coelom. Small cavities appear into the lateral plate mesoderm. They join together and form large cavity that is called as intraembryonic cavity or coelom. It splits lateral plate intraembryonic mesoderm into the two parts. Same way we have seen in extraembryonic mesoderm. Here also, due to the formation of intraembryonic xylem, it splits into two parts. One is called as somatopleuric. Here we have to say intra. So somatopleuric intraembryonic mesoderm, which is in contact with ectoderm. While another part of this intraembryonic mesoderm, which is called as planktopleuric. And this planktopleuric intraembryonic mesoderm, it is in contact with endoderm. So from lower side, in touch with endoderm, that part is called as planktopleuric. Just above that cavity, which is in touch with ectoderm, is called as somatopleuric intraembryonic mesoderm. Now, what does this intraembryonic xylem forms? So, intraembryonic xylems forms basically three important cavities of our body. One is pericardial cavity, another is pleural cavity, and third one is peritoneal cavity. So, these three cavities of the body they get formed from this intraembryonic xylem. Now, pericardial is around the heart. Pleural cavity comes around the lung. And peritoneal is abdominal cavity. Now, another one important structure we should know is septum transversum. Now, what is it? Intraembryonic mesoderm does not get split as intraembryonic xylem does not extend into the cranial to the cardiogenic area. This unsplit part of intraembryonic mesoderm is called a septum transversum. And what is the septum transversum? It is nothing but the future liver and diaphragm. So in our body, liver and diaphragm get formed from the septum transversum. Embryologically, septum transversum is nothing but the unsplit, means that intraembryonic xylem is not going that or not entering into that intraembryonic mesoderm. So we call it as unsplit part. So it is not splitting right, due to that xylem. So this unsplit part is called as septum transversum. And it is most primarily placed later on due to the head fold. Okay, it comes downward and it forms or it's involved in the formation of future liver and diaphragm of the developing baby. So what we have seen, right? So you can see here very nicely like what we have seen till now. So diagram A, here you can see this is the intraembryonic mesoderm. This is intraembryonic xylem. If you take a section of X, Y, you can see here this is the intraembryonic xylem. This is the intraembryonic mesoderm. This is ectoderm and this is endoderm. So one which is towards this ectoderm we call as somatopleuric intraembryonic mesoderm. One which is towards the endoderm we call splanchnopleuric intraembryonic mesoderm. While other the structures, we know that this is a notocord. These are the somites. So paraxial mesoderm. This is a intermediate mesoderm and this is a lateral plate mesoderm. Due to the formation of this intraembryonic xylem here, so it gets split into the two parts. So this is cavity within it. And we have seen this intraembryonic xylem is involved in formation of important three body cavities, that is pericardial, pleural, and peritoneal cavity. Now you can see here this intraembryonic xylem, it extends laterally and it opens into the extraembryonic xylem. So intraembryonic cavity, it combines or fuses with the extraembryonic xylem. This is the complete diagram here, what we have seen till now. Here, the three germ layers are formed. This is ectoderm, this is endoderm, and this is all mesoderm. This, the extraembryonic mesoderm, which is getting formed from multiplication of trophoblast. So initially it is one. So then extraembryonic xylem getting formed here. Due to that, we are getting this the splanchnopleuric and somatopleuric extraembryonic mesoderm here. Now this extraembryonic mesoderm, which is not extending here, and this is connecting stalk formation. While this intraembryonic mesoderm, so it is not splitting here, not going entry here, entry there, and this is nothing but the septum transversum later on. When this the intraembryonic mesoderm, uh, it form the paraxial mesoderm here, and somites get formed. So this is beaded appearance. They are somites. This is a neural plate, neural tube. Anterior it is expanding, forming the brain here and the spinal cord. And here the frame structures of intraembryonic mesoderm. This is a lateral plate mesoderm here. This is a intraembryonic silo. It fuses here. This is a primitive knot and this is a primitive strip. This is a cloacal membrane. This is a procaudal plate, buccopharyngeal membrane. So you can see here, this is joining here with extraembryonic xylem. So you can see here, intraembryonic xylem, it opens laterally, but it communicates laterally with this extraembryonic xylem. So in this way, here we have amniotic cavity. This is ectoderm, this is mesoderm, this is endoderm, this is yolk sac. In early phase, we have seen primary yolk sac, later on secondary yolk sac. In this yolk sac, later on, it remains in the form of vitello-intestinal duct. Meanwhile, this is extraembryonic xylem and extraembryonic mesoderm, all that, and they have a connection here. And this is a connecting stalk. Later on, it forms the umbilical cord. Now it gets shifted from this anterior part to this tail portion or laterally. So we'll see in the development of umbilical cord later on. I hope you understood by this time. This embryo is completely in the form like this. So we get connecting stalk, we get extraembryonic mesoderm here, we get the three germ layers, ectoderm, endoderm, and mesoderm. These two cavities, amniotic cavity, yolk sac cavity. Here the lateral plate mesoderm, we get intraembryonic xylem, and this is extraembryonic xylem. Going to the further development. Again here, if you take a section here, this level, so you can see here, this is the procaudal plate, most anteriorly. Then, where the ectoderm and endoderm, they are in touch with each other. And this, the intraembryonic mesoderm, not entering there. Then this lateral plate mesoderm is getting split by this intraembryonic xylem forming. And what towards the ectoderm we call the somatopleuric intraembryonic mesoderm. One towards the endoderm, which is called a splanchnopleuric intraembryonic mesoderm. And this is the future septum transversum. So unsplit part, because the intraembryonic xylem does not extend here anteriorly. So the part of intraembryonal mesoderm which is not splitted, so that is unsplit part, which is referred as septum transversum. And this is a future site of formation of liver and diaphragm. This is yolk sac cavity towards endoderm. Right? So endoderm, yolk sac, ectoderm, here we have amniotic cavity. Coming to the second part of this today's lecture, that is foldings of embryo. Means embryo get folded. And due to that, various changes occurs in the developing embryo, so they are very important. And embryonic disc increases in size progressively. As growth is there, so it increases in size progressively. The head and tail end of the disc remains relatively close together. The middle portion it proliferates first, so it goes upward. However, increased length of the disc bulges upward. It goes upward into the amniotic cavity. At the head end, that is called as head fold. At the tail end, this is called as tail fold. We'll see all this with the help of diagram in the next slide. Due to the formation of head and tail folds, parts of the secondary yolk sac lined by endoderm get enclosed within the embryo. So this is a change due to this head fold and tail fold. So this tube-like structure lined by the endoderm is called a primitive gut. So yolk sac get converted into the primitive gut, but that endoderm get converted into the primitive gut. From this gastrointestinal tract is formed. So primitive gut will form the GI tract. That it is called as initially the primitive, means very primary phase, gut, gastrointestinal system. This primitive gut divides into the three parts, foregut, midgut, and hindgut. Most anteriorly means foregut. In the middle part, midgut, and towards the tail is called hindgut. So these are the three parts of the primitive gut, and this primitive gut is formed due to the head fold and tail fold. Part of the secondary yolk sac lined by endoderms get enclosed. So it goes within the embryo. That forms the tube-like structure, which is called as primitive gut. Now one should know that vitello-intestinal duct, part of the yolk sac connecting to the primitive gut, is called as vitello-intestinal duct. Lateral folds, embryo also get enclosed on the lateral side as hair fold and tail fold takes place. So from lateral side, lateral fold takes place. This ectoderm encloses embryo from all sides at the yolk sac where it is connected by the vitellar intestinal duct. We have seen that what is the vitellar intestinal duct? It is a part of yolk sac connecting to the primitive gut. This narrow opening is called as umbilical cord. Now, due to this lateral fold, already the hair fold and tail fold is formed. And due to this lateral fold, so ectoderm encloses embryo from outside of the yolk sac where it is connected by the vitellar duct. This narrow opening is called as an umbilical opening or umbilicus. With the help of diagram, we can see here this very early picture. You can see here embryonic disc, ectoderm and endoderm is formed. Later on, the multiplication takes place here, progressive growth. So it bends upward, right? So due to the excessive growth in the middle portion, it bends upward in the amniotic cavity. If you see in the diagram, so it is more progressively bending upward. Due to that, this head fold and tail fold get formed. While this yolk sac, you can see its position, it is going slowly inside, encroaching slowly inside, like this. So head fold comes here, tail fold comes here. This is going inside. If you come to the diagram D, here again this head fold is coming here. From back side, tail fold is coming here. From lateral side also lateral fold takes place. And we get this narrow opening. So in which this yolk sac is going inside. Right? This is the endoderm part, this is yolk sac. So it is going inside. And this is converting into the vital intestinal duct. While this endoderm is forming a tube-like structure. Right? Due to this head fold, it is going here. The tail fold coming from back side going here. And this, the endoderm is converting into the tube-like structure, and this is called as primitive gut. There are three parts of it. One is called as foregut, another is called as midgut, and third one is called as hindgut. You can see here yolk sac, right, converting into the vitellar intestinal duct. So it is connecting this definitive yolk sac to the this primitive gut or endoderm. This is called as vitellar intestinal duct. And this is an umbilicus, right? Umbilical opening. So head fold, tail fold, then primitive gut formation, three parts, foregut, midgut, and hindgut. Now here, just at the connecting stop here, vertical duct, the part in front of it is called as foregut. Part just opposite to it of that primitive gut is called as midgut, and the part posterior to this vertical duct attachment is called as hindgut. These are the three parts of the primitive gut. While concentrate on this amniotic cavity. Initially it is like this. Here it is a yolk sac. You can see here it is covering around the embryo. It is widely covering all over the embryo. This is ectoderm and this is endoderm going inside and mesoderm is in between. If you see here, amniotic cavity is covering from all sides. It is encroaching the developing embryo. And here you can see this huge amniotic cavity, amniotic fluid with there. And within that, all these journals comes inside. Ectoderm, endoderm, and endoderm in the form of the primitive gut, mesoderm in between, and ectoderm here. So this is head fold, then tail fold, around the amniotic cavity going with the amniotic fluid. And this is going to convert in the umbilical cord. So outermost covering in the umbilical cord, you are getting amnion, right? So in this way, due to the foldings, the very changes occur there. Now concentrating on the connecting stop, what happens? Let what changes occurs due to the folding of embryo. Initially formed by unsplit part of extra embryonic mesoderm, to which we call as connecting stop, and it lies at the top. Slowly it gets shifted to the tail end. As the extra embryonic cilium get formed, it shifts this to the tail end. With trophoblast and uterus wall, placenta get formed. In between the all these changes take place, placenta get formed. So it is a connection between placenta and embryo in future. This connecting stop. Once the tail fold forms, it gets shifted to the ventral means anterior part of the developing embryo and becomes narrow and elongated, and this is called as umbilical cord. Also covered from all sides by the amnion. We have seen in last diagram. By that time, blood vessels get formed. So content of umbilical cord is the remnants of the vitello intestinal duct. left umbilical vein. Initially, there are two umbilical veins, right and left. So right get disappears and left remains as it is. So left umbilical vein, one in number, two umbilical arteries, then remnant of allantois. We'll see in the next slides what do in the allantois. Wharton jelly, it is nothing but the embryological connective tissue. It's called as Wharton jelly. These are the contents of umbilical cord. If you see here, if you take a section at this level, so most outermost you get your amnion. Then rest of the remnant of this vital intestinal duct, then you get left umbilical vein and two umbilical arteries, Wharton jelly, and all this covered from outside. That is a amnion. So you can see here this umbilical cord. So concentrating on that, what is here is connecting stop. So you can see here this is connecting stop, connecting stop. Then it is shifting here to the ventral side. You can see the formation of placenta here, formation of placenta. Then this connecting stop is coming here ventrally. Head fold and tail fold takes place. This is yolk cell. Right? So this primitive growth is formed. And when this red placenta is coming here, so this is forming the umbilical cord. So basically, umbilical cord is nothing but a mutually connecting stalk, unsplit part of extraembryonic mesoderm. Later on, placenta get formed in uterus pod here, in touch with this embryo. Later on, this is the connection between the placenta, this black part, this is the developing fetus, and this is known as umbilical cord, future umbilical cord. So here around it, we get all the amniotic layer, amniotic fluid, and this is the umbilical opening. This is a remnant of later on intestinal duct. Right? Later on, after delivery, placenta is removed. This umbilical cord is cut toward this umbilicus, right? Nearby the umbilicus. So connection between the placenta and fetus is cut here. Once the fetus becomes independent. So that is the function of umbilical cord. We can say it is a connection, main connection between placenta and the fetus. So it provides nutrition from mother to the developing baby, and it also transport excretion, waste products from the fetus toward the maternal circulation. So this is cut section passing through the umbilical cord. Outermost you can see amnion. This is the umbilical vein. There are two umbilical arteries. These are the remnants of vitello intestinal duct. And here we get Wharton jelly, means embryonic connective tissue. Right? So this is the structure, microscopic structure you can say, section passing through the umbilical cord. Coming to the allantoid diverticulum. So before formation of tail fold, small expansion takes place on yolk sac into the connecting stalk near the tail end. This is called as allantoid diverticulum. Diverticulum means out pouch-like structure. And this allantoid, which is coming from yolk sac, right into the connecting stalk. After formation of tail fold, this allantoid diverticulum gets absorbed into the hindgut. Later on, this allantoid diverticulum is involved in the formation of urinary bladder. So this allantoid diverticulum is involved in the future development of urinary bladder. It is nothing but outpost-like structure coming from yolk sac. It is going into the connecting stalk. And later on, after formation of fold, it comes on the ventral aspect, which get absorbed into the hindgut. With the diagram you can see here. So this is a amniotic cavity, this is membrane disc, this is yolk sac, this is a connecting stalk. So out of the structure from this yolk sac going into the connecting stalk. Right? So this is called as allantoid diverticulum. Once the hair fold forms here, from here the tail fold forms, and this yolk sac goes inside, right? And this is forming a primitive gut. So you can concentrate this primitive gut is formed. This is vital intestinal duct. While this outpost of structure, right? So this is the allantoid diverticulum. And once the tail fold forms, right? Here the tail fold forms, it comes anteriorly or from the ventral aspect here. Later on, this get absorbed into the hindgut. And this is involved in the formation of urinary bladder. So, with this diagram, one will come to know that what do you mean by allantoid diverticulum, where is its location, and what is its fate, its future structure developed from this allantoid diverticulum that is nothing but the urinary bladder. Okay. In short, we will see what are the effects of this hair and tail folds. Just before formation of head and tail fold, the structures in embryonal disc are in the midline from cranial to the caudal. So one number is septum transversum, second is pericardial cavity, space around the developing heart in the form of tube, procaudal plate, neural plate, primitive strip, and cloacal membrane. So in this diagram you can see, right? So before head fold and tail fold formation, so most anteriorly this is the septum transversum. When you get here, right, the procaudal plate, when you get here the neural plate, right, and posteriorly you get here primitive strip and cloacal membrane. Right? So they are just one below each other. Once the head fold takes from here, once the tail fold takes from here, then right, there is a change. So many changes takes place right in the location. So after the head fold, what happens? Developing pericardial cavity come to lie on ventral side of the embryo, or ventral to the forward. Developing heart initially in the floor of the pericardial cavity. Initially, heart is in the form of tube-like structure, and it lies in the floor of that pericardial cavity. But later on, so it goes up. So developing heart initially in the floor of pericardial cavity, now lies in the roof. So it goes change, location is changed, and it is going to the roof of the pericardial cavity. Pericardium enlarges rapidly and forms bulging in the ventral side of embryo. So developing heart is forming another bulging there. Septum transversum comes to lie caudal to the heart. Caudal is posterior to the heart. The procaudal plate, buccopharyngeal membrane, future is buccopharyngeal membrane. The oral membrane comes to lie cranial, most anterior to the forward. Now the most cranial structure is enlarged cranial part of neural tube, that is the brain forming structure. Below that, the developing heart, another bulging due to the developing heart is forming there. And in between these two bulgings, the depression is getting formed, and this depression nothing but the future mouth, which is called as stomatodeum. So stomatodeum is nothing but the depression between the two bulging. The process is there, and this bulging, one is due to the developing brain, and another is developing heart. So they are rapidly developing, so they create bulging structure there, and in between that, the depression part is called as stomatodeum. In diagram, you will see it very clearly. After tail fold on the posterior side, you get a lot of changes here. Atlantic diverticulum shifts from caudal into the ventral side, anterior side of embryo. Cloacal membrane shifts from caudal to the anterior part of the embryo. The primitive strip gradually disappears and can produce sacropoccygeal tumors in adults. So once the role of this primitive strip is formed, it gets slowly disappear, but sometimes in some people it remains, and it may convert into the sacropoccygeal tumors. So they are coming from the remnants of primitive strip. They can convert into the carcinoma or tumor-like parts. These diagrams will show you the effects of this head fold. This is anterior head part, right? And this head fold taking place here. And on posterior side, right? This is the posterior end, and then tail fold takes place here. Now here we can see in this before forming the head fold, most anterior structure is septum transversum, which is unsplit part of the extraembryonic mesoderm. Unsplit part of intraembryonic mesoderm, which is called as septum transversum. Then behind that you get this pericardial cavity. You can see this dark part, right? So it is nothing but the developing heart, and which is in the form of tube-like structure. The pericardial cavity remains above the heart tube before the head fold. Then you can see this is a procaudal plate, right? And this is a neural plate which is expanding anteriorly. So brain is going to form here, heart is going to form here, and this is a this procaudal plate, right? Now at this tail, as it is thin part, this is heavy part, so it winds downward here and head fold takes place here. Once the head flow takes place here, so what are the changes? See this most anterior part, septum transversum, goes here on the posterior side. Then this is coming most anteriorly to the buccopharyngeal membrane, initially to the procaudal plate. Then as this the developing heart, right, in the pericardial cavity, it is at the floor. But as this changes here, head fold takes place. So this red part, tube-like structure goes above, and this cavity comes below. You can see change in location of heart tube. Initially it is at the root, but it goes to the initially it is at the floor, but it goes to the roof. So this is the change due to the head fold. In this, you can see that most anterior coming here, the procaudal later on we call buffer membrane. And just near to it, we get the foregut here, right? Antemost part of the primitive gut, right? Foregut, then you get midgut and hindgut. So these are the changes. Now we are seeing the stomatodeum also. What is it? It is the depression between the two bulging. So one bulging is due to here, right? Once the hair fold takes place here, embryo bends at this level. So this brain is coming anteriorly. So it is developing or bulging structure here. Another is heart is forming, and this is bulging. So this one bulge, then another bulge, and in between like this depression, right? It's called like stomatodeum or the mouth. Right? So this is a site here, future site of formation of mouth or stomatodeum between the two bulgings. One is due to the brain, one is due to the developing heart. So what happens here at the tail fold? Right? You can see here the primitive stick at this level, it goes anteriorly. Right? And due to that, this the cloacal membrane, right? It is coming here, right? Most anteriorly. Its primitive stick, it is coming here. And see the change in its allantoic diverticulum, which is laterally. And due to the tail fold, it comes out and this ventrally, right? Coming on the front side here. So these are the changes taking at the posterior side. These are the changes taking here anteriorly due to the head fold, and this is due to the tail fold. You can see here septum transversal, so which is taking part in formation of future liver and diaphragm. Then heart tube, right from this roof, slowly comes down. Pericardial space is going to form around it, and from here various chambers get formed. Right, and this is developing brain expanding, then forming here cerebrum, all that. Right, and face is going to form in this region, and this is the mouth. Right, later on, then GIT will form all this here, and from the mesoderm, all the other systems get formed. Right, this is involved in the allantoic diverticulum, involved in the formation of urinary bladder. So in this way, all further changes get stimulated, and at this stage, due to the head fold, tail fold, and lateral fold, umbilicus is going to form here. An umbilical cord is attached at that level, which is the connection between the placenta and the developing fetus. Here we end with this today's lecture. It was a little bit extensive lecture, but see the all further developments, different milestones, right? And understood the changes or effects occurring due to the hair fold, tail fold, and lateral folding, what being by connecting spot, umbilical cord, and rest of the structures what we have seen, right? Like septum transversum, then splitting of interembryonic mesoderm in the three parts, paraxial mesoderm, intermediate and lateral plate mesoderm, intraembryonic xylem formation, then the somites formation from the paraxial mesoderm, and what are the its three subdivisions, what are the structures derived from it. Short note may be asked right on the notocord or on the primitive streak, or short note may ask on the somites, right? So in that all you are supposed to write a paraxin mesoderm. You are supposed to write all these, right? Somatomeres, somites, subdivisions, structure derived from it and all. And head fold and tail fold. These are the areas to understand, right? How this folding of embryo takes place. Then amniotic cavity is going to cover from all sides. The umbilical cord get formed. And allantoic diverticulum, right? So here we ends. Right? We sum up this topic here. Thank you.